So today's class is on KNN, K nearest neighbor. Now, this KNN actually is quite similar to uh, these K-means, and this K-means is for clustering, and KNN is for classifier. And this is a lazy learner that such that it don't train, it just try to find the nearest neighbor. But this KNN has been extremely useful for even chatbot when you try to search which is the answer giving the best. So this is a good algorithm, and this the video will take about maybe less than 5 minutes. So the first thing is that just want to explain to you this. We are using Python and Scikit, and these are the steps that we do usually for only all the sklearn classifier. First of all, we need to put the data in the correct format, the X and Y. Then after that, what we do is that we do some initialization. Then after that, try to train the model, which we call it fit. Then after that, we want to evaluate the model, how good it is. So what does KNN do? So if let's say today we have we are doing iris flower, so there'll be 3NN. So 3NN means that I'm going to put 3 centroid, and I'm to find the nearest distance for this centroid to this dot, to this particular data. However, there's some data in the middle, I may misclassify it, and that's called error. So we're trying to reduce the error as much as possible. So this is the one that we're going to do 3NN. So I'm going to cut short the theory a bit while we can read the notes. And this KNN actually, it tried to optimize the centroid, find the best centroid. So if you look at this iris data, there are 3 flowers. So this is the scattered diagram. And the code in Python, so if you want to run it, it looks like this, the Python code here. So now, this is the first part of the Python. This is a must. Okay, so we actually need to do it. Let me break into these two. This one, just cut it here. The reason is why I want to do that is because this is a must. Okay, and this is the KNN classification, and you can see the accuracy here. So where plotting the graph is optional. Okay, so sorry about that. I think to use the plot here. Okay. So when you plot the graph, right, is whether you want to do it or not. Okay, so it's just to see the visualization that how he can cluster tree, but there's some misclassification also. So you can see there's I mean KNN is not that perfect, right? That's why you have the answer 96.67. Okay, so this is something that KNN is doing well. Then this is the code for the Python. Okay, so this is optional for plotting. Okay, so if you like to plot, then for visualization, so you can use this code. If not, you can just skip it to this KNN, which is the accuracy. Then this is the how it looks like. And of course, it can be done in R code as well. So if you do look at the R code, so look at the R code, you get similar results. Okay, because they're using the same algorithm. Just the output to run it is Control Enter. So let me see, Control Enter. So you roughly can see the final accuracy 97.4. Okay, there's some difference because there's quite a lot of random when you look at the centroid initial point. It need not to be 100% the same because of machine learning. We use a lot of randomness, so there could be a big difference between the two results, and that's the output. And for this, just to also highlight to you that okay, so we also because of splitting of train test set, that we may not have the same results. Okay, so because the output may split differently from the this Python. Okay, so KNN So I think if you can scale it or normalize it, so KNN can find the optimum point faster. Okay, so that's what it means. So there's a good model strength and weaknesses. So this is a lazy learner, so it's actually very fast and you no need to train. Okay, so this is the strength of KNN. And thank you for listening.